Welcome back to the Deep Dive. It is Thursday, February 12th, 2026. And before we jump in, I want you to do a little mental time travel with me, just for a second. Rewind the clock back 3 years into 2023.
Ah, the year of the chatbot.
Exactly.
Yeah.
The year we all just completely lost it because a little text box could, write a poem or a slightly wrong recipe.
Oh, yeah. And then came 2024.
And the buzzword completely shifted to RAG retrieval augmented generation. That was when we figured out how to get the bots to stop making things up quite so much.
The don't hallucinate, just read this document I'm giving you phase. Yeah, that was a huge step.
So here we are, it's 2026. And if you're building anything right now, you know the whole conversation is different. We're not really talking about chatbots. We are firmly, and I mean firmly, in the era of AI agents.
We are.
But, and this is the real friction point we're digging into today.
Yeah.
It feels like we've hit a wall. We have these models, right? They're brilliant. They can pass the bar exam, reason about philosophy. But if I ask one to, say, go into my database, run a quick query, and then slack me the result, it can't. They're like these brilliant consultants who have no hands.
That's the perfect way to frame it. The brain is there, the cognitive engine is running, but they have no way to actually interact with the world.
No interface.
Exactly. They can't click, they can't type, they can't execute anything, and that's precisely what we're unpacking today. The industry has finally started to rally around a solution, a standard to give these models hands.
And that would be MCP, the Model Context Protocol.
That's the one.
It's not the sexiest name, I have to say. It sounds like something from an old server manual.
Yeah.
But the research stack we're looking at today calls it the USB-C of AI.
And that analogy is just so spot on. It really gets to the utility of it. I mean, think about that drawer full of cables everyone used to have.
Still have.
You still have it. A different cable for your camera, another for your printer, some weird dongle for your phone. That is what AI development has looked like for the last few years. If you wanted a model to talk to Google Drive, you wrote custom code. If you wanted it to talk to Salesforce, you wrote completely different custom code. It was, brittle. It didn't scale. And if an API changed, your whole agent broke.
So MCP is the one universal plug that replaces that whole messy drawer.
Exactly. It standardizes that handshake between the user, the model, and the tool. And tool can be anything. Your local files, a GitHub repo, a massive corporate database. MCP just defines the language. It says, this is how a model asks for something, and this is how a tool gives it back.
And that's our mission for this deep dive. We're going to tear apart the 12 frameworks that are driving this whole shift. We've got everything here, from the huge SDKs, from the tech giants, all the way down to the super specialized tools for startups.
And it's important to see these aren't just, a list of products. They represent totally different philosophies on how you should even build an agent. You've got the giants, the connectors, the builders, and then the orchestrators.
Okay, let's start at the top. The heavyweights, the native giants. And I mean, we have to start with OpenAI.
You have to, specifically the OpenAI SDK. Now, most people have used this for a simple API call, but the big insight here is that they've built MCP support directly into the client itself.
What does that actually mean for a developer? Like, no middleman.
Pretty much. It handles the tool registration, the communication with the server, all of it natively.
Yeah.
In the old days, like 2 years ago, you had to manually parse the model's output and try to match it to a function in your code. It was a mess.
I remember.
The SDK now just manages that whole function calling loop. Tools are first-class citizens.
The use case in the notes here is honestly a little terrifying. An AI DevOps automation assistant.
Yeah. This is where we get into production-grade autonomy.
Yeah.
Imagine an agent that's just constantly reading your server logs.
Okay.
It sees a latency spike. It doesn't just send you an alert. It uses MCP to query a monitoring server, confirms the problem, checks the system metrics, and then, this is the kicker, it executes a command to spin up more servers.
See, that's the part that makes my palms sweat.
Yeah.
Giving an AI pseudo-privileges.
I mean, it is risky without guardrails, for sure. But the real benefit of using the native SDK for this is the speed and the reliability. The request isn't going through some third-party layer. It's point-to-point.
The brain is talking directly to the hands.
Exactly. For high-stakes stuff like infrastructure, that low latency is absolutely critical.
Okay, so OpenAI is for speed, a rapid response engineer. What about Google? They've got the ADK Agent Development Kit. Is their approach different?
Very different. If OpenAI is about raw action, Google's ADK is all about cloud-native integration. It's built for Gemini models, sure, but really it's built for the whole Google ecosystem.
This is for companies that are already deep in Google Workspace.
That's the sweet spot. The main use case here is an enterprise financial analytics assistant. Think about quarterly reporting. It's a nightmare. It's usually some poor person pulling data, cleaning it, pasting it into sheets.
Soul crushing, yeah.
The ADK lets an agent connect right to BigQuery, run complex SQL, get the revenue numbers, and then use another tool to just populate a Google Sheet and make a chart. All automatically.
And the key thing is that it's not just reading the data. It's a structured interaction.
That's it. The ADK has the framework to make sure the SQL query is actually valid, that the data is formatted correctly when it lands in the sheet. It basically turns the agent into a 247 data analyst.
Okay, rounding out the giants. Microsoft, semantic kernel. That name sounds very academic.
It does, doesn't it? But it's actually the most corporate of the three, and I mean that as a positive. This is for the big enterprises, the .NET shops, the banks, the companies running their entire world on Azure.
The notes mention ERP enterprise resource planning. That's usually a total no-go zone for AI. The data's just too sensitive.
It is. But semantic kernel is built for that exact environment. It understands and respects enterprise identity, role-based access, all the compliance stuff that, keeps a CTO from getting fired.
So this is an agent that can safely touch the company's central nervous system.
Precisely. An agent that can check inventory in SAP, cross-reference a sales order in Dynamics, and flag a problem. It's not glamorous, it's not writing a sonnet, but it's automating the absolute backbone of a business.
Okay, so those are the giants. OpenAI for speed, Google for data, Microsoft for the enterprise. But I want to pivot to a problem that every single developer listening is just nodding their head at right now.
Let me guess.
Authentication. It's one thing to say, connect your agent to Slack. It is a whole other thing to manage OAuth tokens, refresh tokens, scopes, and keys for thousands of users. It's a nightmare.
It's the bane of our existence.
Do I really have to build all that plumbing myself?
You used to. And that brings us to our second category, the connectors. And the huge name here is Composio.
The notes call it a managed MCP platform. Is it basically auth as a service for AI agents?
That's a massive part of it, yeah. Composio is the middleman. Your agent doesn't need to know how to log into GitHub and Jira and Slack.
It just talks to Composio.
It just talks to Composio. And Composio handles the oat dance, the token refreshes, the API normalization, all of it. The best use case is an AI project manager. Imagine an agent in your meeting. You say, okay, let's track that bug. The agent just tells Composio to create the issue in GitHub, update the sprint in Jira, and then post a notification in Slack.
Without something like that, building those three integrations would take
weeks of coding and then months of maintenance when one of them changes their API. Composio just abstracts all that pain away.
Now, in this space, there's another name we have to talk about, LangChain. I mean, if you built anything in 2024, you were probably using LangChain.
You definitely were. It was the Swiss Army knife. And that's the challenge now, right? There are thousands of apps built on that older architecture. You can't just throw it all out to switch to pure MCP.
Too much technical debt.
Way too much.
Yeah.
So they built the LangChain MCP adapter. It's a bridge. It lets your old LangChain app talk to these new MCP servers.
The example given is upgrading a RAG chatbot from 2024 with, financial calculation tools.
Exactly. You keep your existing chatbot logic, but you plug in an adapter that connects to a math engine or a stock ticker. It's a way to modernize without starting from scratch.
Okay, let's switch gears. We've done the big platforms, we've done the connectors, but what if I'm a control freak? What if I want to build the server myself from the ground up?
Then you are a builder, and for you, the ecosystem gives you the raw materials, the Python SDK and the TypeScript SDK.
Let's start with Python, the language of data science in the backend.
Right. The MCP Python SDK is for when you need absolute total control. The perfect example is a financial tax calculation service.
Because tax law is not something you want an LLM to just improvise on.
Never. The last thing you want is a model guessing your tax bracket based on its training data. You want code, deterministic code. So you write a rock-solid Python script that does the calculation correctly.
And then you just wrap it in an MCP server.
You wrap it in the server using the SDK. So the agent isn't doing the math. The agent is just the interface. It's a receptionist. And the Python script is the expert accountant in the back room. It completely eliminates hallucinations for tasks like that.
And on the other side, we have the TypeScript SDK for the web dev Node.js crowd.
Yep, for the teams building modern SaaS platforms. If your entire stack is Node.js, you don't want to spin up a whole separate Python service. You just use the TypeScript SDK.
And the use case is an AI dashboard.
Right. Connecting to Stripe for billing, your CRM for user data. Because it's TypeScript, it just integrates seamlessly with your existing code. You're basically exposing your own internal functions as tools for the AI, all in the language your team already knows.
Speaking of the stack,
Yeah.
we've been very back-end focused,
Mhm.
servers, databases, but eventually a human has to see this stuff on a screen.
Yeah.
How does MCP change the front end?
This is where it gets really interesting. We're seeing this move towards what people are calling client-side intelligence, and Vercel is at the forefront with their AI SDK.
Vercel, the gold standard for Next.js and front end.
For sure. And their SDK lets you stream these tool responses directly to the user's browser. So imagine you ask an AI on a dashboard, show me my sales for today.
Okay.
Instead of just getting back a sentence, the AI generates a graph component in the UI, and that component is pulling data live from Stripe through an MCP tool.
So the AI isn't just generating text, it's generating the actual user interface.
It's driving the application state, it makes the entire interface dynamic, it builds itself based on what you ask.
Which brings us to Copilot Kit. This seems even more specialized. It's a React framework.
The name Copilot tells you everything. It's about being a sidekick. It lets you embed an AI sidecar right into your app. Think about a super complex admin panel like an AWS with a million menus.
A nightmare to navigate.
Awful. Instead of clicking around, you just have a Copilot Kit sidebar. You type, reset the password for user John Doe.
And the Copilot finds the right internal tool via MCP and just does it.
Yes. It turns your entire application into something you can have a conversation with. The learning curve for complex software just flattens to zero.
That's a huge shift in UX.
Yeah.
But we have one last layer. And this one feels like the most complex. We've been talking about single agents using tools, but real work. It takes a team.
This is the real frontier. Orchestration. How do you get multiple agents working together without, just chaos?
Let's start with last mile. Their focus is workflow-driven agents.
Last mile is for when you have a predictable process. A great example is a content generation pipeline. You don't just write a blog post. You research, then you outline, then you draft, then you edit.
And if you ask a normal chatbot to do that, it tries to do it all at once and just makes stuff up.
Exactly. Last mile lets you define that workflow in a file. It forces the AI to follow the steps. Step 1, use the search tool. Step 2, use the outlining tool. Step 3, write the draft. It enforces discipline on the model.
It's a deterministic pipeline for a non-deterministic model.
That's a perfect way to put it. Now contrast that with Strands, which is about runtime orchestration.
What's the difference there?
Strands is less about a rigid path and more about monitoring a dynamic situation. The example is an autonomous customer support system that can issue refunds.
That sounds dangerous.
It is. You don't want an AI just giving away money. So Strands acts as a monitor. It watches the execution. If an agent tries to refund more than, say, $100, the orchestration layer can step in and require a human to approve it.
It's a safety net.
It's human in the loop as a structural guarantee. It lets you deploy these agents into really sensitive environments.
And finally, praise an AI. This gets us to the multi-agent system.
This is the virtual boardroom. Praizen lets you create separate agents with specific jobs. The use case is a competitive market analysis system.
So instead of one genius AI,
You have one agent who's just the researcher. Its only job is to scrape pricing data. Another is the analyst, comparing features. A third is the report writer.
and they all talk to each other.
They communicate via MCP. The researcher passes data to the analyst, who passes insights to the writer. It mimics how a human team works, and it prevents context overload on any single model.
Now, we've walked through the whole landscape, the giants, the connectors, the builders, the front end, the orchestrators. It's a lot.
It is a massive explosion of new infrastructure, yeah.
But if you had to boil this all down for someone listening, a CPO, a lead dev, what's the headline?
The headline is that MCP has officially moved us from the experimental phase to the infrastructure phase of AI. In 2023, we were hacking prompts. In 2026, we're engineering systems.
It's not about who has the smartest model anymore.
It's about who has the best connected, best orchestrated system of tools. Connected, orchestrated, tool-driven intelligence. That's the game now.
So what's the advice?
The advice from the research is really practical. Start small. Don't try to build some 10-agent autonomous company on day one. Build one MCP server, connect it to one tool, get that solid, then add another. Once you get the protocol, scaling is just adding more connections.
It really feels like we've crossed some kind of threshold. We spent so long teaching computers to think, and now we've finally given them a standard way to act.
And that just changes the definition of software, from something you use to something that works with you.
Which leads me to this final thought I want to leave everyone with. If we have this standard protocol, this USB-C for AI, where an agent can read code, write code, and execute deployments,
Yeah.
are we heading towards a world where software just maintains itself, where the role of a human developer shifts from coder to, I don't know, architect of agents?
Hmm?
Or maybe just supervisor?
That is the big existential question we're all going to be wrestling with for the rest of the decade.
Something to think about. Check out the show notes for a list of all 12 of the frameworks we talked about today. Thanks for listening to The Deep Dive.
See you next time.